Kia ora. We're going to have a look at the excellence Poisson question, and this one comes up a fair amount, and it's a very easy way to get an excellence mark. And an excellence mark means you instantly pass the exam. When I say quite often, it's probably less than half the time, but pretty close to half the time. Okay, on a different Pacific island, the probability that there are no cyclones, look at this, no cyclones in a year, that means Px equals 0, is equal to 0.4493. Calculate the mean number of cyclones that strike the island in a year. So we are trying to find, oh, okay, well they can give us that here, 0.4493. Okay, so we want to know what is lambda. Now, this is going to require a tiny bit of algebra that you can just rote learn, but I find this really interesting. Now, on the right of the screen, you can see this formula. Probability that a random variable takes the value x is equal to lambda to the power x multiplied by e to the power of negative lambda over x factorial. This looks scary, I understand that, but it's so straightforward once you know just two facts, right? The two facts are this. 0 factorial. What the heck does factorial mean? Factorial just means you multiply the number down. I'll just show you an example. Right, so 3 factorial is equal to 3 times 2 times 1. So you just multiply down until you get to 1. And that is 6. 2 factorial would be 2 times 1. And then that would come out as 2. 1 factorial would be 1. Now, the wacky thing is that 0 factorial is equal to 1. Kind of weird, but I could explain it, and I might do that in another video, but it doesn't matter too much. All you need to know is that 0 factorial is 1. The other thing you need to know is that anything like the letter n to the power of 0 is also equal to 1. That one's a little easier to prove, but yeah, you can actually prove this one by doing this same thing here. Look, 2 to the power of 0, oh no, 2, okay, let's do this. 2 to the power of 2 equals 4, because it's 2 times 2 is 4, right? 2 to the power of 1 equals 2, because it's just 2. Now, the difference, to go from here to here, you just divide by 2, so we just do the same to go from here to here. So you divide by 2 when you're moving down it. So we divide by 2 here, so that is why anything to the power of 0 is going to be 1. It's not really a full proof, but I don't think you guys care too much. These are the two things you got to know. Anything to the power of 0 is 1, and 0 factorial is also 1. And 1 is one of the easiest numbers to deal with in maths, so that makes this really straightforward. Okay, let's actually do this question. Px equals x is equal to lambda to the power of x e times e to the power of negative lambda over x factorial. Looks scary, don't worry about it. Now, let's write out what we know. Well, we know that it's Px equals 0 is this, so we know what that is. That is 0.4493. So 0.4493, which is Px equals 0, is equal to, what is lambda? Lambda is what we're trying to find, so we'll just leave that as a lambda to the power of x. Now, x is 0, so it's just lambda to the power of 0, and we're multiplying it by e to the power of negative lambda over, and x is 0, so it's 0 factorial. That's what makes this question so easy. It's just something to the power of 0, which is 1, over 0 factorial, which is 1. Right? So it ends up being that 0.4493 is just equal to e to the negative lambda. So it breaks it right on down, because this is equal to 1, and 1 times anything is just itself, and it's divided by 1, so anything divided by 1 is just itself. So this is all we have to work out. 0.4493 is equal to e to the negative lambda. Okay, now is we actually have to probably know a tiny bit of maths. The only thing you need to know is what e is and what is e's opposite. So this is the other fact. E is opposite to this little button ln on your calculator, right? Ln just means log base e, and log base e is, logs are just a way of getting rid of exponents, right, or powers. So see how this has got a power on it? It's e to the power of negative lambda. We can use ln to do the opposite. So if we take the ln of this side, so I'm going to do it over here, ln of 0.4493, and then I take the ln of the other side, ln of e to the negative lambda, these things cancel each other out, and it gets rid of the fact that that's a power. So actually, what is ln of 0.4493? We can do that on our calculator. You've got an ln button, so you just go ln, look at that, beautiful, ln of 0.044, oh shucks, not, why did I put another 0 there? 4493. See? Okay, so negative 0.8. Or do I do my full? I'm just going to leave it to that. I'm going to do it to 3 dB, whatever. Equals negative lambda. What the heck? That's easy as. Then we just get rid of the negative, right? So therefore, lambda equals 0.8. That's it. That gets you an excellence. And then we're just going to do that. We'll do it one more time. Let's just skip a question, eh? If the neighbouring delicatessen, I probably need to know a little bit. What the heck? If the neighbouring delicatessen, okay, sells no jars of pickled snails in 56% of weeks, so P x equals 0 equals 0.56. That's all we need to know. That's it. Everything we need to know. So now we know, let's use our formula. 0.56 equals lambda to the power of 0, e to the negative lambda over 0 factorial. Right? And then these things, they both become 1. Maybe I should show you that here. I'll show you how fast you can do it once you know. 0.56 equals e to the negative lambda. And that's sort of crossing over the 0. Don't get too confused by that. So then all we need to do is take the ln of both sides, ln of 0.56, so I'll do that here, ln of 0.56 equals negative lambda, so therefore 0.5798 equals lambda. That's it. That's all of the working that you need to do to get an excellence mark. And you get an excellence mark, you pretty much instantly pass your distributions exam. If you were like a real gambler, this would be a technique to learn. It's going to have it's a high risk but very high reward. So that's not even high risk. What do you mean? This takes like flipping, how long is it going to take you to learn? These are the 3 facts you need, and then you can just sort of crunch through it. Okay, there is one more scenario. This is the other scenario. This one comes up quite a bit, so we'll do question 4 as well. The neighbouring, I think they've done it wrong. This should just be a delicatessen, right? A delicatessen, and then it goes, the neighbouring delicatessen sells at least 1 pot of jellied eel in 35% a week. So Px at least, how do we write at least 1? X is greater than or equal to 1, and that is 0.35. So we can use this information, right? So this is at least 1. So then what's P x equals 0? Because that's the only one that we can use to find find lambda. So that's just going to be everything else, because this is at least one jar or pot, right? And then so 1 minus 0.35 is going to get you how often they sell 0 pots, so that's 0.65. So that's what we're dealing with. We know px equals 0, 0.65, so therefore we know 0.65 is equal to lambda to the power 0 e to the negative lambda over 0 factorial. Let's go through to the same process. Maybe I'll do a little bit more working out this time. Equals 1 times e to the negative lambda over 1. Alright, that's all we're doing, but you can totally skip that step and just go straight to there. Right, so therefore 0.65 equals e to the negative lambda. I'm going to do like a line down here so I know my working is moving over. So then we do the opposite of e. I'm going to do a little bit more working here. ln of 0.65 is equal to ln of e to the negative lambda. But ln cancels out this e to the power. Right, so then ln of 0.65, let's do that. So negative 0.4308 is equal to negative lambda. So lambda is equal to 0.4308. That's how you do excellence questions. Poisson. Oh, let's see if there's anything else worth knowing. In a cave, a biologist examines many species. Ooh. Okay, so look at this. Oh no, I don't want to tell you this. It just uses the fact that it's proportional, right? That Poisson is proportional. They're first looking at 1 square meter, and now they're asking you about 4 square meter. So each one, she found at least 1 in 64% of these sections. Calculate the probability of finding no more than 3 weta in a 4 meter square section. I'm going to leave you guys to do that one. Okay, the table shows a probability distribution for the number of wasps. There are no fewer than 2 in a 5 hectare. Okay, so this one here, they're giving you the whole table, and you only need this piece of information to make a model. 2 and then 5 hectare block. Ooh, it actually looks interesting. I'm low-key tempted to do it. Yeah, I'm too tempted. I'm going to do it. I'm going to give it a go. Okay. So let's use what we know, and I'm just going to do big skip ahead. Like, check this out. So when we've got a px equals 0, so when lambda for this is 1 hectare, and let's find our lambda value, and we're going to skip right ahead. So check this out. All you do to skip ahead is all we actually need to do is we get this starting number, so in our case it's 0.644, and all we do is we'll just get the negative ln. I'm totally skipping it. So negative ln, this is, you can do this in the exam, you'll still get full marks. This is a bit of a hack. So look at that, I got my lambda value. I should really write that. Negative ln of 0.644 equals 0.44. Okay, so lambda is 0.44. Let's double check that that's right. How we can do that is I could just go and look at the Poisson distribution for that. So let's go PPD, and we will look at x equals 0, where lambda is 0.44, and we hope to see this probability pop out. Voila! Yeah, look at that, cheat mode. You will get full marks for doing that. It's crazy, but yeah, you could either learn some maths, learn that maths, and then you have a process, or you can just memorize to the negative ln of 0, yeah, of the whatever the probability x taking 0 is. Kind of bit of a hack, but yeah, you go for it if you want. Okay, now it's proportional. So this is our 1 hectare. When you're dealing with 1 hectare, lambda is 0.44. So they want to know 5 hectare. So that's so now we're going 5 hectare. Our lambda value is just going to be 5 times 0.44 because it's proportional. Right? That's all it is. So do we do that in our heads? No, we cannot. 44 times 5 times 2.2? 2.2. Right? We've got a value here. So our lambda value with a 5 hectare is 2.2. And now let's see what question they're asking. There are no fewer than 2. So they want to know P. No fewer. Oh shucks, that English is getting to my head. No fewer than 2. No fewer. So maybe they want to know Px is 2 or more. I think that's what they're asking for. The probability that the wetters showing up, wasps nests showing up is greater than or equal to 2, because no fewer than 2. The number 2 is not fewer than 2. The number 3 is not fewer than 2, but the number 1 is fewer than 2. So that's what they are asking for there. So can we do this on our calculator? No, we cannot. So it's equal to 1 minus P x is less than or equal to 1. So that there we can do in our calculator, or we can just do the probability x equals 0 plus the probability x equals 1, but we ain't peasants. Okay, lambda value was 2.2, and they want to know 1 or less, so cumulative up until the number 1 equals 1 minus 0.3546, and that is 0.6454. Voila, I'm glad I did that question. How satisfying, how fulfilling, how wonderful that question was. Good night.